I will have a more theoretical presentation compared to you, so it's very technical, and I will be talking about how the blockchain can strengthen the Internet of Things. This is the content I will be going through. I will first briefly explain what the Internet of Things is, and then I will explain an incident that happened related to it, called Mirai botnet. Then I will talk some about how blockchain and IoT can be used together, and also how the blockchain can be incorporated into the IoT security, and also be used for identity and access management systems. I will then talk about some challenges in IoT that can also be addressed using the blockchain, and also how blockchain can ensure supply chain security. So first off, we're going to talk about the Internet of Things. Internet of Things is regarded as a system or device which has the ability to transfer data over a network. Simply said, it's an object connected to the Internet. And the Internet of Things now are becoming more pervasive and smart, and also cheap and easily employable with examples like CCTV cameras, smart fridges, smart clocks, and etc. And also these days, this smart IoT, like driverless transportation, drones, autonomous cars, and smart homes and smart systems are becoming very big words in today's society. But the Internet of Things also has some limitations with limited computing and storage capabilities. And also the IoT application and research are still in the very early stages, and so there's little effort in the security, but more effort about getting product up and going. And this can lead to incidents. So in October 2016, the US-based DNS provider DIN was attacked through a DDoS attack, distributed denial of service attack, using a Mirai botnet malware. And what this caused was that much of the internet on the US East Coast became inaccessible for several hours or up to a day. And they figured out that a lot of this traffic came from IoT devices, where this malware had used the script to use the default login and password to log into a lot of IoT devices like CCTV cameras, DVD players. And also this Mirai botnet was released to the internet, so it is open source, and even now there is coming later version of it or mutations. So now I'm going to talk about the blockchain and IoT. One of the drawbacks of the IoT application and platform is the reliance on the centralized cloud. In the cloud model, the IoT devices are identified, authenticated, and connected through cloud servers. And the connection goes exclusively through the internet, no matter the distance. So even if some projects are just a few feet apart, it still has to go through the internet. And the problem with the cloud model is that we will not be able to respond to the growing needs of the huge IoT ecosystem in the future because of the scalability. And so the question is, can blockchain strengthen the Internet of Things? And researchers have concluded with the answer maybe, where they believe that the decentralized and blockchain-based approach can overcome many of the problems associated with the centralized cloud approach, as the combination of IoT and blockchain is very powerful and set to transform many industries. An example given is that the IoT devices can carry out autonomous transactions through smart contracts, and this impact can be even more significant when you involve big data and artificial intelligence. But what role can blockchain play for strengthening IoT security? I'm going to be talking about two companies that use or incorporate blockchain into their platforms, their IoT platforms. So first is IBM with their IBM Watson IoT platform. It still uses a large cloud infrastructure, but to provide blockchain services for taking high-value items as they move, for tracking high-value items as they move across supply chains. The built-in capabilities of this platform allows users to add selected IoT data to private blockchain ledgers that can be included in shared transactions, and all business partners can access and supply this IoT data in a decentralized fashion and can verify each transaction. So it's very easy for a company's business partners to check because of blockchain's publicity and auditability, but this can be done using a private blockchain, so it's only visible to the parties involved. And the data is not collected, stored, or managed centrally, but rather protect and share among the other parties involved in the transaction. And another company is Filament, which is a blockchain solution provider, where they made something called TAPS, which is a wireless sensor. And what they do is they create a new business model, eliminating the needs of centralized cloud servers. And what these TAPS can do is they can allow communication with computers, phones, or tablets within 16-kilometer radius, and they create a low-power autonomous mesh network that enable companies to manage physical mining operation or water flows over agricultural field. And so how this works is that the device identification and intercommunication is secured by a blockchain that holds the unique identity of each of the participating tap or node. And these nodes or the sensor are connected in a decentralized system and use autonomous smart contracts. This way, the devices can communicate securely with each other, exchange values, and execute actions all automatically. For example, an instance given is taps can be attached to drilling rigs in remote location, and based on the predefined condition, they can send requests to an autonomous drone when it requires a piece of machinery, and all of this can be done automatically. And now to identity and access management system. The blockchain-based identity and access management system can be leveraged or used to the maximum potential to strengthen IoT security. The blockchain has already been used to securely store information about the goods' provenance, identity, credential, and digital rights. And as long as the information entered into the blockchain is accurate, a blockchain's immutability can be achieved, which basically means that it cannot be altered or changed or removed. So private blockchain can be used to store cryptographic hashes of an individual IoT device's firmware, and this will create like a permanent record of the device's configuration and state. And what this can do is that we can use this to verify that the device is genuine and not tampered with. And after this verification, we can only then allow a device to connect to other device or services. This is like a verification to make sure that the device is genuine and has not been breached. This will provide a stronger defense against attacks involving IP spoofing or IP address forgery, where the later versions of the Mirai botnet I mentioned earlier has been using IP spoofing attacks. So what the blockchain does is its immutability makes it not possible for devices to connect by disguising themselves by injecting false signature into the record, as it's not possible to alter an approved blockchain. And now I'll be talking about some other challenges in IoT where blockchain can be a potential solution. First is the cost and capacity constraints. Gartner estimated that in 2016, 5.5 million new IoT devices were connected every day. And in the IoT devices, it's a challenge to handle the exponential growth. And by 2020, it was estimated that network capacity at least 1,000 times the level of 2016 will be needed. And so the amount of communication that needs to be handled in such a network model will also increase the cost exponentially. So by using the blockchain, there will be no longer need for a centralized entity, as devices can communicate securely, exchange values with each other, and execute action automatically through smart contract in a decentralized way. Another problem is deficient architecture. Each block of IoT architecture acts as a bottleneck or a point of failure and disrupts the entire network. Vulnerability to distributed denial of service attacks, hacking, data theft, and remote hijacking also exists. And so if an IoT device which is connected to a server is breached by one of those said attacks, everyone connected to the server could also be affected. So the potential blockchain solution is that by using blockchain, secure messaging between devices can be done, and the validity of a device's identity is verified, and transactions are signed and verified cryptographically to ensure that only a message's originator could have sent it. Using this can eliminate the possibility of man in the middle, replay, and other types of attacks. Another problem is the cloud server downtime and unavailability of services. Cloud servers are sometimes down due to cyber attacks, software bugs, powers, coolings, etc. And so by using a blockchain, the solution is that there's no single point of failure, as the blockchains or the records are on many computers and devices that hold identical information. So even if one of the computer devices is down, there's always another one where you can extract information. And the last problem is susceptibility to manipulation, which means there's a high likely to be manipulated. Information is likely to be manipulated and to put to inappropriate uses. Companies that can believe their evidence will lead to higher costs or even lawsuits, and so censor, edit, or delete their information in their favor. And so the potential blockchain solution is using a blockchain, as blockchain is decentralized and also immutable. Malicious actions can very easily be detected and prevented. And because devices are interlocked, if once blockchain updates are breached or edited, the system will reject it, and so you can easily prevent the manipulation. Lastly, I will talk some about the blockchain's role in improving overall security and supply chain, where we can see this picture here. And we can see with blockchain's public availability, it's possible to access immutable records, where we can see in the upstream supply chain, we can use a blockchain to trace back products to the origin of the raw material that's used in, for example, making devices, and pinpoint also the source of the problem / parts of the items. And in the downstream supply chain, partners / owners, device owners, you can easily identify users of the vulnerable devices and guaranteeing return of products in case of recalls, and registering updates, patches, and part replacements throughout the lifetime of the product. Now, this can also be used, if adopted on the supply chain, to better handle cyber attacks. For example, the Mirai attack I talked about earlier, where IoT products with vulnerability to malware could easily be recalled to prevent incident. The original problem with this was, however, that it's difficult to determine a device's owner, but using the blockchain, which is very suitable for complex workflow, it can be easily used to register time, location, price, parties involved, and other relevant information when an item changes ownership. And that way, it will be way easier to track the progress in addressing vulnerabilities or when a device's owner change, and also to track the device's owner. And also can send warnings and notification to the owner, for example, when a device is vulnerable. So in conclusion, the future looks promising for the use of blockchain in addressing IoT security, as the key security challenges associated with the cloud, which is today used mostly in the IoT platform, can be addressed by using decentralized, autonomous, and trusted capabilities of the blockchain. Blockchain's decentralized and consensus-driven structure are also likely to provide more secure approaches as the network size increases exponentially, and it will also most likely lower the cost. Because blockchain-based transactions are easily auditable because of its public availability, it can play a key role in tracking the sources of insecurity in supply chains, and it can therefore handle deal with crisis situations such as product recalls that occur after safety and security vulnerabilities are found. Blockchain-based identity and access management systems can also address key IT security challenges, for example, like earlier explained, IP spoofing. And that's my sources, which is mostly and blockchain strength internet of things paper.